We know this because of the autoionization of water. H plus, bless you, H plus and H3O plus mean the same thing. Okay, so if you know one of these, you can find the other by simple math. If you take the log of these, you will have pH plus POH equals 14. So if you're given a POH and they say find the H plus, then you're going to plug this value in, find your pH, and then your H plus would be 10 to the negative pH, right? So H plus is equal to 10 to the negative pH. OH minus is equal to 10 to the negative POH. pH is equal to the negative log of H plus, and POH is equal to the negative log of OH minus. So you can use this or this, and you can use these, but these two are very good for if you're given hydroxide, find H plus. If you're given pH, find hydroxide ion concentrations. But these are the most useful formulas in these questions. Okay? $150 is equal to 1 times 10 to the negative 14. So divide both sides by 0.150. And you've got your H plus concentration.
So H plus is the same as H3O?
Yes. One's informal, one's formal.
Okay. So H plus is H2O, it's an acid.
Yep. So because this solution is high in hydroxide concentrations, it's basic. And if you take the negative log of this, you'll find out what the actual pH is. So the pH is, sorry? 13.5? Thank you. Can you give me one more digit? 47? Okay. Thank you. There's 2 significant digits here, so there's 2 decimal places in our pH. Remember that.
This is very acidic.
Okay.
So that means it has a pH of...
So when this dissociates, it will pop off 1 barium, 2 hydroxides. So the concentration of hydroxides will be twice the concentration of the base. So your concentration of OH minus will be 0.50. Now try and find the pH. So you're going to do it this way, and then you're going to use this. So you're going to subtract the answer here from 14. Or you're going to find Your hydroxide ion concentration is 0.5, so you're going to use that, and then take the negative log of your answer. So there's two different ways you can do these questions. You either do it this way, or you do it this way. There is a question like this on your final exam. Okay. What type of a compound is it? Two words. Second part's acid. Carboxylic acid. So your functional group is that. Out of all the hydrogens, that's the only acidic one. Often we write the H out front. Is this triprotic, diprotic, or monoprotic? Monoprotic because there's only one H plus that comes off. H2SO4 would be a diprotic acid. There's two acidic hydrogens. Phosphoric acid. Triprotic because there's H3PO4. Okay?
Take off all three H's?
You won't necessarily take off all three.
It just means that there are three.
There are three. So in the right situations, you could get all three off. But generally, no. All right. So we know this is an acid because the pH is low. Right? It's lower than 7. We know it's a weak acid because it's a carboxylic acid. We know its concentration and we know its pH. Before you even do any questions, is there anything you can calculate based on that information that might be crucial?
The concentration of H3O plus.
Yeah, the concentration of your H plus. So, bless you. So if you find yourself on a quiz or a test or an exam, you don't have a clue, but you've got a pH, calculate H plus. It's just like the rule in grade 11. You don't have a clue, calculate moles. Bless you. We're going to use that because I haven't actually asked you the real question yet. Nope. Okay, so tell me, what is the hydrogen ion concentration? What'd you get? He's at least answering questions. Okay, so percent ionization, how much of the acid actually becomes this?
That's going to be always percent ionization?
Yes. What did I say it was? 0.46? Okay, so how much? How much? 0.9%? I saw it. 2.9. Thank you. That's how much you got? No, can't be. Because you got 2.9 divided by 0.46, so it can't be 2.9.
It's 0.63.
That's what I got.
Anybody else get that?
Wait, no, 0.63 is.
0.63, sorry, my mistake. Okay.
We is computer now.
So, does this ionize very much?
No.
No, less than 1%. So it's a weak acid.
It's a baby acid.
And a strong acid, this number would be close to 100% or 100%. Because you have, this was HCl, you'd have none of this left in solution. None of it. All of it will ionize. Weak acids, though, only partially ionize. So that's when this drawing came in. If this is a weak acid, you've got lots of actual molecules still in solution. But if this is a strong acid, you have no molecules left in solution.
And it's safe to touch.
Vinegar is, right? That's the one on the left, acetic acid.
What's the one on the right?
That's orange juice on
That's hydrochloric acid. That's the stuff in your tummy.
See?
Mole per liter solution. I want to know what the pH of this final solution is. Okay, so I want you to just look at the board for a minute. Look at this substance. Is this one of your 6 strong acids? No. So its H plus concentration is not this value. If it was HCl, that would be our H plus ion concentration. Pretty short question. If this was H2SO4, double that. That's your H plus concentration. Pretty quick question. This is a weak acid. So guess what kind of tables you have to use? Ice tables. Do you want to do informal or formal? Informal, thank you. Just means I have to write less. Okay, so here we go. Whatever, your H is either going to be here or over here. If it's out here, what's left is everything else with a -1 charge. So it doesn't matter that you've never seen this thing before. There you go. You can write the chemical equation for it. And everything would be AQ. So now we're going to have an ice table. I'm going to put my ice table down here. Initially, how much acid do we have? What value? 0.25, because there's only one substance here. It's 0.25. Initially, you won't have any, because nothing has happened yet. Go through your change. Reactants are negative, products are positive. So you've got 0.25 minus X, X, and X. So this is our values at equilibrium. So we want to solve for X, because that will be our H plus concentration. And pH is negative log of H plus. So we want to solve for X. Once you've set it up, X times X over 0.25 minus X And your Ka value was 9.8 times 10 to the negative 5. So we could totally move this across, multiply it, equals x squared, solve for quadratic. But we're chemistry people. We want to be efficient. So perhaps 0.25 minus x, 0.25 divided by 9.8 times 10 to the negative 5, maybe that is greater than 1,000, which would be very convenient, because then we could say it is. Beautiful. So we've just simplified this. So take 9.8 times 10 to the minus 5, times it by 0.25, find the square root, and we've got x. Anybody get 4.95 times 10 to the negative 3?
Yeah.
Beautiful. That, of course, is a concentration, so you have units. That is our H plus concentration. Find the negative log of that number and you've got your pH. What'd you get? Okay, Carrie, you need to, there's 3 significant digits here. Well, technically we should have rounded to 2 significant digits, so put 2 decimal places in your pH. So what'd you get? 2.31.